Hi, welcome back. So in this video, we are going to be working with user interfacing. So we're basically going to be manipulating the events, key presses, mouse movements, mouse presses, things like that, and actually integrating it into our canvas so that we can reflect those changes and use them to create some user interaction with our animation. So the first thing we're going to deal with is mouse movement. Now what you can do is use event listeners to track when you move or when you do certain events. In this case, when you move your mouse, which gives us a certain property or object that we can use to get some information about that event. So what I'm going to do is select one of these squares and basically attach it to the mouse. So every time you move the mouse, it sets the position of the square to that mouse. So what we're going to do is add an event listener. So to do this, you do document dot add event listener. The first thing is a string that indicates the event that you want to use, which in this case is mouse move. And then you add a function that you want to run every time this event happens. So we're going to be running an anonymous function to do this. Now what I'm going to say, just for demonstration purposes, is we're going to be changing the position of the first square. So in order to do this, we're just going to use our basic properties that we have set up in our objects that we created. Now what you can do is basically add an argument to this anonymous function. You can call this whatever you want, event, really any name, that is going to contain a bunch of information about this event. So what we need from this is the x and y coordinate of our mouse. And this is going to follow the same coordinate system as our canvas here. So what we're going to do is set this to e.clientx. So this property is stored in this event. Every time it happens, it gets the x and y coordinates of our mouse, and then we can use it to our advantage to set this square's property. So now we're going to say square0.y equals e.clientY. Now if we save and move our mouse here, and I need to make sure this is squares, not square. And then when I move my mouse here, you can see that every time I move my mouse, it attaches this square to my mouse right here. Now, of course, it isn't going to be perfect because this only changes when the mouse moves. It doesn't attach it permanently. It still goes through this loop and tries to move away from me. But you can see that every time I move my mouse, it moves all of these squares, or well, just one square towards me. Now, of course, this is just a demonstration, but you can get as creative as you want with this. You can move all of them around, you can change their orbit, you can basically keep track of your mouse and use it wherever you want. So now we're going to go over the keyboard. So the keyboard is a very, very powerful tool, especially here. We can change a ton of stuff, and what I'm basically going to do is set it up so that every time you press a certain key, it increases the size of our squares. We're also going to set it up so that it decreases the size. Now we're going to set up the exact same system as before. We're going to go document.addEventListener, and now our event is going to be key down. So this is when a key is pressed down. And then we're going to add our anonymous function with our event argument. So now what we need to do is set it up, and now we're going to set up a switch statement. So what this is going to do is allow us to switch or go through a list of conditionals and check each of these conditionals, and it's just a fast way of doing a bunch of comparisons. So the reason we need to do this is because the actual key that's pressed is stored in a property called e.key, but we need to check that the right key is pressed. And since we're going to go through multiple of these conditions, it's quite fast to do it with a switch statement. So what we're going to say is switch and then e.key, and now we're going to add all of our cases. So the first case or comparison that we need to do is checking if this key is the key that we want pressed. So in this case, what's going to happen is I'm going to say W is the key that I want pressed if I want to increase the size. Now we're just going to add whatever we want to do and then break, which breaks out of the switch statement once the case is fulfilled. Otherwise, it will keep running through all of the other cases. Now what we need to do is basically create a function that will run and increase the size. So we're going to go up here and we're just going to call it size up. Now I'm going to leave it blank for now, but I just want to make sure that it's there to fill out when we're done. So what I do is call size up and then break out of the switch. Now we have another case, which is S, which is going to be the key to go down. Now to keep consistent, I'm going to call this one size down, and I'm also going to break once it's over. We also add a default case to here, although it's not necessary, in which we just return and break out if none of these are fulfilled. So now we have both of these set up. Let's actually go ahead and fill out the function. So what I'm going to do is loop through our squares and add 10 to both the width and the height properties that are stored in these tracking objects. So what I'm going to do is set up a basic for loop. I is less than 50, I plus plus. And then I'm going to get the exact square that we want through our index and set the width value to plus equals 10 so that it adds 10 to it. We're going to do the same thing to the height. Now for our size down, it's almost identical, but we need to make sure that this doesn't go negative. So what I'm going to have to do is add a little conditional at the beginning, and we're going to say if squares I.w is greater than 0, just to make sure that it's not at 0 and then it keeps going negative. And then we go minus equals 10. We do the same thing for the height, and that's it. Now let's go and test it out. So I'm going to go and click on here, and of course our mouse event listener is still here. I click W, it increases the size. I click S, it decreases the size. And if I keep clicking S, it stays at 0. So this is a pretty basic demonstration, but you can see that it can get extremely powerful once you integrate it into your main sequence here, and you can do all sorts of stuff with it, and you can make it as creative as possible. But this is basically the system that you need to actually get your user integration working. You need event listeners with event tracking, and then you can do whatever you want with them. You can run functions, you can even integrate it directly into your main update loop, which actually is preferable for large projects, and just pass this event as an argument to actually deal with it. So you can do really whatever you want. But now we have a basic animation working, and from a totally static page, we now have all of these squares bouncing around with live tracking of our keys, and they're all responsive and able to adapt to boundary cases and these edge cases. So I hope that gave you a little insight into Canvas and how to use it to create animations. Now, of course, as I said at the beginning of this series, this is just a basic example of how to get things working, mainly to teach you all of the systems that you can use to create these animations. It is really up to you to go as crazy and as wild as you want. I encourage you to download this file and maybe experiment. Use different shapes, use different animations, updates. You can even go really wild and just totally rewrite all of these event listeners and make these as crazy as you want. If you want to do something that's basic or something that's more coherent and applicable to a large project, you can do whatever you want. But now that you have the basic knowledge of how to create a system like this, you can go and apply it to your projects.